Welcome to Chapter 9, which is all about hypothesis testing. So far we've really only had one way to test if a statistic is a reasonable estimate of the population, or if a claim from a population is somewhat true or reasonably true. And so we're going to go into hypothesis testing, which is another way to test things like that. So instead of having a confidence interval. So anyways, today's just kind of some definitions, nothing too super exciting, but we're going to look at some real data as well. So today we're going to have our SWBAT is going to be to state correct hypotheses for a significance test about a population proportion or mean, and then interpret p-values in context. And the kind of overall problem that we're going to be looking at is about Dawson School. And Dawson's pretty proud of the fact that they have many students of diverse backgrounds. And you said, I want to test this claim. I want to see, how diverse they actually are. So, according to the Center for American Progress, you find that 30.6% of Coloradans are people of color. If Dawson were a school that randomly chose its students from the Colorado population, which we know isn't the case, right, because people pay to go there, but if it were random and a good representation of the state, it should have a similar proportion of students of color. And so you set up a test to check this hypothesis. So basically you would end up taking a sample and then from that sample making some observations and doing some calculations and figuring out if Dawson's claim to be representative of Colorado is true or not. So that's kind of our overlying example today. So in order to do that, we need to define a few things and kind of look at meaning of a few words and things in the chapter. So the first thing is a significance test, which is really a formal way to compare observed data with a claim. So comparing your sample statistic versus a claim of the population parameter. So in science class you're used to one hypothesis that you're testing, but in stats it's a little bit different because we have two hypotheses. We have the first hypothesis, which is called the Null Hypothesis, which is basically whatever the claim was already. So the parameter equals the claim. So in our case, we're trying to test whether or not the Dawson population is representative of the state of Colorado. And so we would set up our null hypothesis to be that the proportion of students of color in Dawson is the same as the proportion of the state. So it looks something like this. H0, or the null hypothesis, is that P equals 0.306, which is the proportion of the state. Keep in mind that your hypotheses are always about the population. So this is P or mu. It would never ever be P hat. It would never ever be X bar. So, because you're testing stuff about the population. Then your alternative hypothesis is basically your parameter. You're basically trying to disprove the claim. And so you want to test perhaps that the true parameter is either greater than the claim or less than the claim, or perhaps just not equal to that. And it depends on the scenario which one you want to use, but that's set before you do the test. So you don't want to do your calculations and then figure it out and then go back. That's really bad stats. So you set it ahead of time. So in our case, if Dawson has a larger proportion of students of color, then we would be happy because they're proud of it and we're higher than the population of Colorado. So that would be cool. Basically, we would want to test whether or not the proportion of students of color at Dawson is less than 0.306. So that's kind of the thing that we want to prove. So depending on what you're testing, your your alternative hypothesis can either be one-sided, so less than or greater than, or it can be not equal to, which is a two-sided test. So eventually what we're going to be doing is we're going to be saying, okay, assuming that your claim is true, what's the probability of getting this certain statistic from the sample that I took? And so that probability is called the p-value. So, p-value, the probability, assuming the null hypothesis is true, that the observed value, or the statistic, would take on that particular value that you got, or anything more extreme than that. So this is a good thinker question. So the smaller the p-value, what can you say about the evidence for or against the null hypothesis? And since your p-value is the probability of getting a statistic of that value or anything more extreme, the smaller that p-value is, that means the smaller the likelihood is that you would actually get the observed value, assuming that the null hypothesis is true. So, smaller the p-value, you can start thinking that the null hypothesis is less and less true. Ish. So then, next, and I think this is our last vocab word for the day, is the level of significance. And this is set up ahead of time. So before everything else, it's either given to you or you decide it. When in doubt, the typical significance level is 5%, but it'll usually be given to you. Anyways, it's denoted alpha, little alpha, and it's the p-value at which we decide to either reject the null hypothesis or fail to reject it. Never say accept, just an FYI. But anyways, so perhaps you would be given, okay, test this at a significance level of 5%, and then you get your p-value to be something smaller than 5%. At that point, you would say we reject the null hypothesis at a level of significance of 5%. So that's kind of what we're going towards. The other thing is that if the p-value is less than alpha, then we say that the data is statistically significant. So just another thing. Yay! Alright, so here's your example. I've already done part of it for you. It says state the null and alternative hypotheses for the problem about diversity at Dawson. So we already wrote those down, so I'm just going to carry them down. Basically, right, your null hypothesis is the claim is true, and the alternative hypothesis is the claim is not true. And we're going to test it. Little side note, just make sure to remember anytime you're using any variables, you have to define them. Otherwise, we have no idea the context, we don't know what anything means. So please make sure that you're defining your variables. Okay, next question. Say that after some calculations you figure out that the p-value for the scenario is 0.03 after a sample is taken. And don't worry, later on in the chapter we'll figure out how to actually calculate the p-value. But for our scenario today, we figure out the p-value was 0.03. Interpret this p-value in context. And basically all that 0.03 means is that assuming that the null hypothesis is true, so assuming the true proportion of people of color at Dawson is 30.6%, then the probability of getting the statistic that they got, which we don't know yet because I didn't give it to you, would be only 3%. So that's a pretty small amount, but that's how you would interpret it in context. Alright, so lastly, if you set your significance level at alpha equals 0.05, would you reject or fail to reject the null hypothesis? Namely that the proportion is what they claim. And then what about if your significance level was 0.01 instead? And so in the first case, if alpha is 0.05, 3% is less than that, and therefore we'd reject the null hypothesis. If our alpha level is 1%, since 3 is greater than that, then we would fail to reject the null hypothesis. Remember, fail to reject, not accept. Never use the word accept. It's like in a jury, if somebody's proven not guilty, they're not proven innocent, they're just proven to not have enough information to prove that they're guilty. And that's our intro to chapter 9. Yay!